Alright, the answers to those 6 problems are on the board. 7, you should have used sine, so added them together, got sine of 30 and 1/2. Number 8, you should have added them together, because remember it's the opposite, so cosine of 90, which is 0. For 9, you should have been looking at your numerator and added them together, so tangent of 45, and got 1. For 10, you should have been subtracting, so sine of negative pi over 2, so negative 1. Won't let me go down further. For 11, doing the opposite, so subtracting to get negative pi over 3, so 1/2. For 12, subtracting to get 135, so negative 1. Questions on any of those? So remember, anytime that the formula is laid out for you, you shouldn't be trying to solve it. You should be working backwards. Yesterday, we went through how to go from our our sum and difference to our double angles. Today we're going to actually use those double angles. Alright, so we're going to start off with number 26. Notice that this one asks you to find the sine double angle, the cosine double angle, and the tangent double angle. Pay attention to problems later because it may just ask you for one of those and may ask you for all 3. Just pay attention to that. So anytime it has 2 theta inside, that is your double angle. So also pay attention to that. It does not mean 2 times whatever. It actually means your double angle formula identity. So in order to do this, we have to look at a couple different things. Where would this be? In the third quadrant, which makes sense as to why sine is negative. When we find cosine, it will also be negative, but then tangent will be positive. So knowing that information helps you determine the sign of those values. This piece that we're about to do is not new. We've done this part before. We need to find cosine and tangent by remembering that this is y over r and finding x. Remember, your r cannot be negative, so the y has to be negative. And using Pythagorean theorem. So you have 1 plus x squared equals 9, x squared equals 8. And then when you take the square root, you have to simplify as well. What would that be simplified? 2 root 2. Right now we're just looking at the positive values of this, but when we remember where we are, we're in the third quadrant, we have to magically make them negative. So cosine would be negative 2 root 2 over 3. Magically making that negative because it's in the third. Why is it? Why is it what? This is over r. Cosine is x over r. Tangent of theta would then be sorry, say it again. Yeah. I'm gonna do that work to get there, but it is root 2 over 4. So those just tell you what sine of theta is, what cosine of theta is, what tangent of theta is. Not what your double angles are. You still need to do that work. So in order to do that work, you're using these three formulas. Pick one of those for cosine. You don't need to do all three. I'm going to do that down here. So for sine double angle, I'm going to take sine of theta, which is negative 1/2. I'm sorry, negative 1/3. I don't know why I said half. And I'm going to take cosine theta, which is negative 2 root 2 over 3. And multiply. So once you have your sine, your cosine, your tangent, you just need to put them into your formulas and simplify. Notice that our double angle is no longer negative. That's okay. Just our sine theta needed to be negative. Our cosine theta needed to be negative. Questions on that piece? Again, for cosine, you can use any of the three. Pick which one you like the best. I like this one more than others, so I'm going to use that one. And I'm going to use those two values, put them in, and square them. So you could do it all at once. I take it one at a time so I can see what I'm doing. Because this would become positive 4 times 2 over 9 minus 1 over 9. So 8 minus 1 all over 9, or 7/9. I should write equals cosine.
I apologize.
Did you practice something?
Why is it? Oh, that's what sine was. Other questions on this?
So wait, what's the difference between like the sine to theta and like just normal sine?
So one is the double angle formula for sine. One is sine of whatever that angle is.
Okay.
Okay. Now, this next part, you can do one or two things. You could, if you remember that tangent is sine over cosine, you could do that. Use the two numbers you have from your double angle formulas. Put this over this, simplify it, and get tangent. Or you can use your tangent double angle formula. Either one will work as long as you're using the double angle values, not the originals. If you use the originals for sine over cosine, then it will mess everything up. Tangent we figured out was root 2 over 4. So I'm just going to put root 2 over 4 every time I see a tangent. Again, you could do this all at once, or take it step by step. That's completely up to you. I simplify in pieces. So simplifying the numerator, I'm going to square this before I do anything else. I could also simplify this, but I'll write it down here. I need to get common denominators, combine these fractions, and then eventually I have fractions within fractions. So multiply by the reciprocal of the denominator.
Sorry.
No, you're good.
Hey, don't be rude, okay?
So if you did sine over cosine, you should have still gotten 4 root 2 over 7, depending on how you did that. And if you chose to do a different cosine one, you should still get the same thing, as long as you're doing your math correctly. What questions do we have about this process?
How did you go from 1 8 to 1 8 minus 1? Oh, no, man.
That's disgusting.
It's not. Spring is coming. I saw geese the other day. I saw geese.
I saw geese in the middle of December.
Yes?
You know, when you think about it, it's like a road going through. I know.
It's going through what?
No, I don't know. That is that's why
As you're going through these problems, I would pay attention to your x, r, y, see if any of them are Pythagorean triples. If you go to this one, number 28, you'll see that you have tangent, which is y over x, which means r has to be 5. So if you know 3, 4, 5, I don't remember any of the ones right now. If you remember those, that may help you so you don't have to go through all the work. You can still do that, but instead of going through all that work, I think there was a typo on this also. Because this is the second. This should have been negative. So pay attention to that because I don't type perfectly. But that was a typo. Tangent can't be negative in the second, or it can't be positive in the second. It has to be negative. Cosine would be negative, yep. So cosine is negative 3 over 5. Sine is positive 4 over 5. Just by knowing your x, r, y definitions for those three and your Pythagorean triple, you eliminated using Pythagorean theorem. Now that you have those three and you eliminated that work, you could go into your double angle formulas. I'm not going to do that. I'm going to let you do it. So I want you to go ahead and try the rest of 28 and 27. I think that's the one we didn't do. And then we'll come back and we'll talk about those answers.
No, I don't. I said you were talking.
The tickets are still
$7 but we still lose every game.
That is the only thing that they see it. Exactly. Shut up. It's literally the only place you can sneak into overtime.
The only
They
reason
don't
you
play.
guys, the only reason you guys get a crowd is just because the spirit the section.
Oh, you guys say I could go to freedom. Nobody, somebody in the class doesn't play.
Yeah. Keep dead.
Is there another thing?
I just don't understand how all these people that can play football just don't play football well together. Each of you individually can play football, and when you get together, it's like you're
Instead of 15, like, okay, guys, we're gonna run the ball. Like, we didn't do that 3 hours before, and now it's gonna work.
Okay.
When we
Why
need
are they
15
that
so
So I guess your offensive coaches are bad. Everyone hates. Why does every single football player suck?
Okay, I got that one.
Then get a new football coach.
Yeah.
Sorry, I need to back. You guys can complain. You're the one playing.
No, she removed me. Yeah, she removed me because I didn't let her fall.
You leave the problem. She won't get a new coach. If you get a new coach, you guys still suck, and that's on me.
She hasn't?
No, you don't even live on.
I told you to don't cry.
It was, I know, because even like we had that she playing for like every day tells me now, like they still suck. Like that's I understand. And she's like, I'm gonna go send the password to GPC and her go to college. Yeah, I know.
But now our
Oh.
I was like, oh, she keeps me far. What's your concern?
If your defense was
Okay.
that tough,
You're not
you'd be
looking
losing
for
games like
Okay, got it.
7-7.
Okay, I just want to
Yes.
and I accepted it.
It's not because.
Alright, check your answers. For 27, I have the double angles over here. I have just the, whatever they were, the sine theta, the tangent theta on the right side.
Oh my gosh, you did it right.
Okay, next year.
Do we have questions on 27?
Everyone needs to take them. Our tennis team is like that. Yeah, I know. Our wrestling team.
That was so embarrassing. You should play your phone.
It actually wasn't.
That was so embarrassing.
I don't think I was there. I'll do it again.
Do it.
That's so embarrassing.
Wow, so embarrassing.
Oh, shut up.
Just play your phone.
Boys basketball is like that now. Okay. Boys basketball used to suck.
Okay.
And they're so good. I miss it.
Okay.
Alright, so I'm working out the tangent double angle one for 27. In our numerator, this would just become negative root 5.
You have all the things.
You can have regular good players on one. You can have 5 good players.
This denominator piece is going to become 5 over 4. Get common denominators, combine the fractions.
Because you go against people that have good all of them. That's kind of how it works.
When I actually combine those, I get negative root 5 over 1/4. And then I still have fractions within fractions. So I'm going to multiply this by its reciprocal.
Because you can't bring them all.
I think it was still. Oh, this was.
We're having a CC.
Okay, that's why.
You can't.
I was like,
You can't play defense on 5 people by yourself.
Okay,
You never see that.
I forgot the negative one.
I had folks.
So for these, you cannot leave fractions within fractions. You need to keep simplifying.
Because our
For 28,
what's he gonna do?
you should have gotten these 3 double angle answers.
That's what we do.
7 over 5.
Run more.
It's not that.
Maybe I should. I should get 7 over 5. Or negative.
If you can, if you want to win.
Oh no, those are just, that was
If you only
just
want
say,
Okay. Wait, why is
It's adapting.
why isn't the 24%
It's adapting. That's what we have.
Because I thought the negative, it was like 8 over 3.
No.
And then
We're
the
not
whole
going
time
by
like
age.
8
We're not
over
gonna
3
do that.
times
Right,
negative.
then we talk about it, are you running?
It was negative 8 over 3 over negative 7 over 9, so the two negatives cancel.
A different
Oh,
way.
that's how you got
Is
this.
it fast enough?
No, it's if I back.
Or even looking at these two, if I did sine over cosine, I'd have two negatives.
If you all play football outside of school, there's generic ways that you all go, which means you can run the
For
play.
sine and cosine.
Even if you have no idea. You guys have played
Alright.
for each other for a long
So just like we did yesterday, we are going to go from double angle to now half angle. This will be the last type of identity we do. Now I will say this process
In
is
what ways?
a little long, so memorizing the formulas would probably be easier, but I'm still going to show you just in case you want to see this. So if we're going from double angle to half angle, guys, be quiet. We are going to use just a couple of the double angle formulas, not all of them. I'm going to start off by using cosine's double angle formula. So this is if you wanted to go from double angle to half angle without memorizing them, you could do this. So in this sense, I'm going to solve for sine. Get everything away from sine. So subtract 1. Sorry, that wasn't supposed to be 1, it was supposed to be 2. I wrote the wrong number. Right? It was... No, I wrote it completely wrong. It was 1 minus 2 sine, sorry. That was the one. Okay, that looks better. And now I'm going to divide by -2, but I'm going to do that in 2 separate steps. Because I want to change my signs with my negative so that these two switch places.
Thanks for asking.
This door,
Yes.
change what's being surprised.
Hmm.
How can we just change what's being
If you multiply each thing by a negative, you're changing the signs for this to be a negative and this to be a positive. So I just switched them. Then I can take the square root of both sides. In this case, for your half angles, you do need the plus or minus on the outside. Eventually, you only need one of them, but that will be determined by your problem. Right now, this is just sine of theta, so sine at some angle. But because we're dealing with half angles, I'm going to take all of my thetas and replace them with thetas over 2. So change all the thetas to thetas over 2. When we do that, these 2's cancel, and I'm left with the half angle formula for sine. Which is the one that is written in your notes.
So that's the final.
That's the final.
What is a
Think about it as just as it is. So if you know all the angles on the unit circle, 180, half of that would be 90. You're doing all the half angles of it.
But why can't you just like look at mine?
So 180 obviously won't be one that you get.
Okay.
Wait, can you just like give me a picture of the test so I can just put the angle in half?
But then you wouldn't be able to figure out the exact value
But
without using the calculator. This is how you do it without the calculator.
why can't I just do a row?
Listen, I don't make the curriculum, I just teach it.
Yeah, listen, bro.
Yes. Don't make them play or hate the game.
Yeah.
Yes.
Yes. Miss Storm agrees.
No,
You
no.
play. I hate the game,
Mrs.
bro.
Storm, you weren't here for that conversation. Yeah, because you were late, Mrs. Storm.
Sorry.
Alright, we're gonna do the
Oh, yeah,
same
Mrs.
thing
Storm, sorry.
with one of cosine's other double angle formulas. Cosine 2 theta equals 2 cosine squared theta minus 1. Same process. Get everything away from the cosine that's squared. Add 1, divide by 2.
Yes, sir.
Woohoo! So we kind of skipped a couple steps in this because the 2 wasn't negative. Take the square root.
Shut up.
So now we're at this step. And to get to our final, I'm going to change all of my thetas to thetas over 2. I know these two are going to cancel. And I'm left with cosine of theta over 2 equals plus or minus cosine of theta plus 1 all over 2.
Wait, why is it cosine? Can you repeat that last step that you just did go over the...
You should change all of your thetas to thetas over 2.
Oh, okay.
Now, I'm going to show you how you go from your double angle tangents to half angle tangents, but I would say just memorize your tangent half angles, one of them, just because this process is a little complex. Alright, so with this, I'm actually going to take the fact that we know that tangent is sine over cosine. So I'm going to go back to where I had sine squared over cosine squared. I just want to make sure I said that right there. So I'm going to go back to this piece because we know tangent is sine over cosine. Somewhere in here we have sine squared and we have cosine squared. So I'm going to put this over this. When I do this, I'm going to just make these thetas instead of theta over 2, or 2 thetas. In this, I have fractions within fractions, so multiply by your reciprocal. Here, your denominator cancels. You're left with 1 minus cosine theta all over 1 plus cosine theta.
You said we should probably just memorize this one. Yeah, just memorize it. That is
And if we're trying to get tangent by itself, I'm going to square both sides and make this theta over 2 at the same time. Yes! So this would be your first tangent half angle. You could use this one and not use the other, but this one has the plus or minus, and you have to do the square root, so it's a little bit complex. Tomorrow I'll show you how to get the other two, and then we'll actually use this.